Good day, everyone. Good day, Dr. Emeldrito Valles, our professor. I am Avelino V. Casilan III, and my task for this day is to discuss regarding reading as a neurophysiological process. They say that reading is a neural activity. Changes in the brain result from each reading that you do. Whether you will continue to read or turn to another activity depends on the connections that are made in the brain while you read. Lack of success in learning to read may be caused by irregularities in the brain as it processes sensory data. Now, let's discuss neurons, the messengers of the brain. It actually tells us that special nerve cells which makes it possible for the brain and other parts of the body to send signal back and forth. Neurons are the messengers of the brain. Your brain is a complex organ, unlike any other part of your body. Everything you do, feel, and think involves many areas of the brain. Do you know that when you blink, many parts of your brain jump into action? Think how many of its parts are involved when you drive or play a video game or even read. Your brain, like the rest of your body, is made up of a huge number of cells. Some of these brain cells are special nerves called neurons, which make it possible for the brain and other parts of the body to send signals back and forth. You might call neurons the messengers of your brain. Helping the neurons are the glial cells and the cerebral spinal fluid. The glial cells surround each neuron and act like a net to hold all its delicate place in bathing the neurons and glial cells, the cerebral spinal fluid, among other things. This special fluid helps neurons under messages. The neural transmission process. What does a neuron look like? How does it send and receive messages? Imagine the neuron as a spider attached to a filament. The spider is the cell body. The filament is the axon. The spider's legs are the dendrites. The process through which the neuron sends and receives messages starts when the dendrites picking up the signal from adjacent neurons and passing into the cell body. If the signal is weak, the message disperses and dissipates in the synapse. If the signal is strong enough, 60 to 10 millivolts, the axon passes it along to its endings, a synaptic knob, where it's received by the dendrites of the next neuron. The process is repeated until the message is analyzed and stored by the brain and the reaction made. Seen through a microscope, neurons look like a piece of sod with buffling intertwining of roots. This is because the neurons intertwines with others as much as 600,000 times. But do you know that at no point does any of your neurons touch another neuron? How then does the message relay take in place? So pretty much as what you can see on the screen, this is the direction of nerve's impulse. So meaning, regarding this one, an analogy by Calvin and Ojemarie 1994 makes this clearer. Neurological studies have shown that the axon actually comes at the dead end just outside another cell. There is really a gap, rather like the no man's land between the two independently maintained border fences of neighboring countries such as Israel and Syria. This gap is called the synapse, which might be called the boarding crossing point, where the output of the neuron's axon becomes the input to another neuron dendrites of the cell. Electricity carries the message through the neuron except at the synapse itself. Though only a tension of a volt from bottom to top, a neural impulse is the biggest voltage seen in your brain. What crosses at the synapse, however, is chemical information. Imagine opening a bottle of perfume at one border fence and letting the molecules waft across the no man's land or the synapse to the other border fence when they are sniffed by the dendrites on the other side. This is according to Calvin and Oheman, 1994. So, with this, I will show you there is a unipolar neuron, multipolar neuron, and bipolar neuron. Now, let me discuss to you the types of neurons. There are three types of neurons according to their functions in the relaying of neural messages. We have the receptor neurons, connector neurons, and the effector neurons. So basically, these three will help us and they will give us more idea on how messages are transmitted. First is we have the receptor neurons. These are neurons that can be found in the eyes, ears, skin, joints, and various organs. These neurons have dendrites that are very sensitive ways. For example, those found in your eyes are very sensitive to light waves, while those found in your ears are extra sensitive to sound waves. Receptor neurons also pick up changes in your body's position as well as changes in the tension of your muscles. Next, we have the connector neurons. As you might have guessed by their name, from the linkages between most of the neurons in the central nervous system, they make up more than 9 billion of the 10 billion neurons in your body. They make up most of the brain, the spinal column, and the major sensory nerves such as the optic and the auditory nerves. They make up most of the reticular formation, the limbic system, and the cerebral cortex, which analyzes and stores languages. Then we have the effector or the output neurons. Neurons have axons that terminate in your muscles and gland where they excite reactions. So those are the three types of neurons. So next is we will proceed the brain mechanisms of language. So there are actually four brain mechanisms for language reception. We have the sensory system, reticular formation, limbic system, and the analysis and storage system. The sensory input system includes the specialized sense organs and neurons which receive sensory stimuli and relay these to the brain through the spinal cord. Clearly, for reading, the visual and auditory systems are very important components of the sensory input system. So, as the word implied, the sensory input, meaning those messages that we actually receive using the sense of hearing and our sense of sight. Imagine the amount of information that the sensory input system is receiving and sending every second. How does your brain cope with this staggering number of messages? Your brain simply select what is important and ignore the rest. So that's how really important our brain. Imagine even they receive a lot of information, they can still filter what messages should be kept and delivered. Next is we have the reticular information. On this one, in biological terms, this is the thalamus found in the midbrain. Meaning, the reticular formation operates like a very busy switchboard, deciding what to do with the incoming and outgoing messages. It can send incoming messages on up to other parts of the brain, or it can cancel them. Wow, imagine, that's the thalamus. For instance, if your friend calls you while you're reading a good book and you don't honestly hear him or her, it may be because the reticular formation didn't pass the message of your friend's voice. Reading may have seemed more important to you just then. So that's the use of the reticular formation. So meaning he can actually decide whether the message or the things you want to hear, where you will give importance to that, or you will just not actually give importance to that message. Then next we have the limbic system. Is interconnected with the reticular information. In biological terms, this is the hypothalamus, located just in front of the thalamus. This system controls your emotions, including pleasure and punishment mechanism. Informally, the limbic system is referred to as the motivation center of the brain. Well, so meaning the hypothalamus is the one who actually controls the emotions that we felt, even it's for pleasure and for punishment. So meaning the hypothalamus referred to as the motivation center of the brain. So these messaging chosen by a reticular formation together with the emotion linked to it by the limbic system is then carried to appropriate parts of the brain for analysis and storage. So on this one, about to take a popsicle stick, it is the most recently developed part of the brain. It allows you to do so many things, things that only humans can do. Within the two hubs of cerebrum, there are centers for each of the major learning senses, the sight, the hearing, and touch. You do not use much of your senses of smell and taste for learning, so their centers are located deep within the brain system area. The section of the cerebrum that is under the bumps on the back of your head takes care of visual information. Or every sight that you see, another area toward the sides of your head takes care of oral information or all sounds that you hear. Meaning for reading, we actually not give more importance to the sense of smell and taste. What we usually use with our senses is the sense of sight, hearing, and touch. So there are areas that make you aware of what you really touch. These are located around the area where our white headband would sit on your head. The motor strip, which takes care of muscle control, is just in front of your imaginary headband. A simple way of describing a cerebrum, especially the cortical areas that cover, is to say that it controls a great deal of what makes you special and nearly all of what makes you different from others. So those are actually the lobes of the cerebrum. So those are actually the way that the parts of the brain that really gave us the meaning or really provide us information on how the neurons as physiological process delivers the messages with the help of the parts of our brains. Next is we have, of course, the eye movements in reading. So for the eye movements for reading, we have this, what we called fixation, interfixation movements, regression, and of course, we also have this very important part, the return sweep. Fixation is actually the stop that your eyes make so that you can react to what you are reading. The length of this pause includes both seeing and thinking time. You must have time to see and process the stimuli. The length in terms of words and frequency of fixations vary, depending on the difficulty of the reading material. Your facility in word recognition, your familiarity with the content, and the format of the printed page. For example, you will tend to make more and longer fixations if you are reading difficult material. So again, fixation, it's actually the stop that your eyes makes you so that you can react to what you are reading. So it's actually one of the movements of the eyes. So a study by Buswell found that the average child in grade 1 made between 15.5 and 18.6 fixation per 3.5-inch line, while the average college student made only 5.9 fixation on a line of similar length. Another study reports that the average first grader makes about 224 fixation per 100 words, while the average college student makes about 90 from the Chant 1964. So imagine the difference between a grader and a college student when it comes to fixations. Your eyes move from left to right during the interfixation movements. When you take in data, your eyes converge during the interfixation movement, but diverge during the fixation that follows at this time stakes. You use about 92 to 94% of reading time for fixations, while you use only 6 to 8% of reading time for interfixation movements. A regression is a reverse movement from right to left. This is actually the movement of the eyes when we are reading. You make regressions when you return to a previously read letter, syllable, word, or phrase for refixation. What causes you to regress when reading? A number of reasons: eye deficiencies, or habit, or when the flow of thought is interrupted, or when you think you have made mistakes. So that is regression. So meaning um, it's a reverse from actually right to left, meaning when you are left behind, when you oversee letters or you don't understand words, you go back to that word again so that you can analyze that. So the reasons that we have regression is that eye deficiencies, those are actually problems with their eyes, or a habit, or even when the flow of thought is interrupted, even when you're doing something, you don't understand the line, that's it. When your eyes reach the end of one line of print, they make a return sweep to the beginning of the next line. This takes about 40 to 54 milliseconds. If you miss the next line entirely, or if your eyes land on a point before or after the first word of the new line, you must locate the proper place. This requires refixation. So basically, that four movements are actually important in reading. So we should be aware, we must be aware of the different eye movements, like the fixation, which is the full stop of when you're reading. We have the interfixation movements. We have the recession, the reverse part when you actually miss something when you are reading. And of course, the return sweep. As the word implies, the return sweep. So, what is this passage about? The procedure is quite simple. First, you arrange things into different groups. Of course, one pile may be sufficient depending on how much there is to do. If you have to go somewhere else due to lack of facilities, that is the next step. Otherwise, you are pretty well set. It is important not to overdo things. That is it. It is better to do few things at once than too many. In the short run, this may not seem important, but complication can easily arise. Soon, however, it will become just another facet of life. It is difficult to foresee any end to the necessity for this task if the immediate future. But then, one can never tell. After the procedure is completed, one arranges the materials into different groups again. They can be put into their appropriate places. Eventually, they will be used once more, and the whole cycle will then have to be repeated. However, this is part of life. By Bransford and Johnson, 1973, page 400. General principles of human information processing. This is for additional input. Noise, anything that makes the build-up of information within a message unclear or which conveys no information, it's merely a noise. So that's the definition of noise. If there is no information, if there is no comprehension needing, with the message being relayed, so it's merely a noise. Uncertainty. When there is more than one meaning to those from in making sense out of a message, that is uncertainty. We are not sure of what he or she is trying to imply. Redundancy. The features of the message that makes the meaning of the message clearer. That's redundancy. So pretty much that's all my report for this day. Thank you so much everyone for listening. I'm again your discussant, Mr. Avelino V. Casilan III. With that, thank you, God bless, take care.